Okay, so here we have a situation where we've got a little wagon. It's attached to a rope, and up here there's a little pulley. And this guy right here is he's walking this way and pulling this rope, and so it'll pull the wagon in. So the question is, what's the speed of the wagon? How fast is this wagon getting pulled when it's 12 feet from the pole, assuming the rope is being pulled at 1.5 feet per second? Okay, so let's do step one is to, of course, draw a picture and label. So let's say that, so we know this guy is 10, and so we need to label this guy right here, this rope. So let's label that H. And since it's saying that it's being pulled at 1.5 feet per second, that's talking about the rope. So that's how fast this guy is changing. So dH over dt is equal to 1.5. Now you have to be careful though, because it's being pulled at 1.5 feet per second, which means this guy is going this way. So H, notice, is getting smaller, so the rate has to be negative. Okay, and then D, so we have X, and then this guy right here, dx over dt, this is what we're looking for. This is how fast this guy is moving. And that's when, according to the rope, when according to the problem, when x is equal to 12. Okay, now step 2, find a formula that relates all of our information. So if you look at this, well, it seems a bit obvious that the Pythagorean theorem would be the best bet. So the Pythagorean theorem says that x squared plus, now here it's not 10 squared because 10 is the entire height of the pole, and we're this wagon is being grabbed from right here, so it's going to be 8 squared, and that's going to equal to h squared. Okay, so step 3 then is to find the derivative of both sides with respect to time. And so the derivative of this guy is 2x dx over dt plus 0 is equal to 2h dh over dt. Okay, and so then that means, so step 4, we plug in all our stuff. So let's see if we have everything. We have x. We know x is equal to 12. Dx over dt, that's the one that I'm looking for, so I'm just going to leave that one there. H I don't actually have, but I have that, I know that x is equal to 12, so if I draw my little triangle here, I'm looking for h. This guy is 8 and this guy is 12, then this guy would be the square root of 12 squared plus 8 squared. And dh over dt, we already said that was negative 1.5. And another thing I can do is I can divide everything by 2 to get rid of those 12s. So if I plug all that stuff in, I would get that dx over dt is equal to negative square root of 144 plus 64 over 12 times negative times 1.5. And this is this is equal to negative square root of 13 over 2. And this is in feet per second. And notice that the answer is negative because the distance x is decreasing. So that's why this guy is negative. And that's it.